Hello, I'm Eric Snodgrass, and thank you for watching this Thursday night, May 25th In-Depth Ag Forecast brought to you by Nutrien Ag Solutions. If you don't mind, I want to do something a little different tonight. I'd like to start off with kind of a narrative, a story about everything we're dealing with this year. And it begins with this guy right here. In the early 1900s, this man here named Sir Gilbert Walker was installed in India as a part of the British in their attempt to predict the strength of the Indian monsoon. His predecessors did a terrible job of this, trying to forecast the strength of that thermally direct circulation, and they were associating with some bizarre things like flooding in the Nile or interesting weather in Brisbane, Australia, and they were kind of missing the bigger point. So being a physicist and a mathematician, he came in there and said, I need data. He started collecting it. And with time, using some very brand new and amazing techniques at the time, like autoregression, multivariate analysis, and things like this, which are quite commonplace nowadays, he discovered that what was really going on with the behavior of the strength of the Indian monsoon, which again is a thermally direct circulation that just draws tremendous amounts of moisture off of the Indian Ocean, then deposits a lot of it right here at the base of the Himalayas, but throughout much of India. What he discovered was what really controlled the Indian monsoon and its strength was the oscillation in trade winds. In fact, he called it that. He called it the southern oscillation. And what he was talking about was that normally across our planet, we have right here along the equator winds on the northern side of the equator that come out of the northeast, and on the southern side that come out of the southeast. And they essentially just blow and converge right here along the equator and create rising motion somewhere, okay? And what he found was that these winds had an oscillation to them. They didn't always behave in a very predictable manner. They oscillated in their strength and moved back and forth. Now he called it the southern oscillation, but it turns out the full name of what he discovered is called ENSO, E-N-S-O. He gave it the S-O part, the southern oscillation. The E-N part is El Niño. And that word comes from Peruvian fishermen right here who coined the term El Niño because the typical time when these oscillating trade winds would become to the point where they would start to allow, because of being weak, warm water to slosh back over here toward Peru, basically shutting down their fishing industry. They found that the typical timing, the arrival of those warmer waters, happened around the Christian holiday of Christmas. And so they named it El Niño, referring to baby Jesus. So that's where this all comes from. But this was the scientist that really discovered what I'm about to explain to you. And this is what we named after him. It's called the Walker cell. So if you look at any given time, this is what the wind pattern across the open Pacific looks like when things are normal. The trade winds blow this way. There's rising motion here. The flow goes back across the top and sinks. So therefore, we push a lot of warm water there. We have a lot of cold upwelling here, which is why there's such nutrient-rich waters for those Peruvian fishermen to fish. And by the way, a lot of them fish for anchovies. That's what's fished here. But sinking motion dry, rising motion wet. Okay. What he discovered is that the trade winds don't always do this. And sometimes they did this. Instead of being in their normal phase, they sometimes really accelerated, increasing the rising motion, giving us major rainfall over Indonesia and Malaysia, the Philippines, and also here into Australia. And that circulation was just kind of on steroids. And sometimes it went into a very weak phase. And what he discovered was the weak phase, which we call El Niño now. And that's when, instead of having the strong trade winds like this, they're weak. See them right in through here. The rising motion is no longer over Indonesia and Malaysia and Philippines and Australia. Instead, it's somewhere out in the middle of the Pacific. And it just tends to alter global weather patterns because this is kind of the longest west to east expanse of ocean on the planet. It's right along the equator that receives all the heating. And it's a part of the whole transfer process of heat and momentum out of the tropics. So everything that I've been telling you about for months is honestly just because of this guy right here. All right. Now, you might be asking a question. If he was able to discover it, does he know why the trade winds oscillate? The answer to that is no. We don't yet know why they do. But we know this is the result. When you look at the time period we're in now, May, and we're heading toward August, the heart of this growing season in the Northern Hemisphere, and you look at those trade winds, and you look at the years when you have El Niños and La Niñas, either, and you correlate them, this is what we find. If the ocean temperatures are warm here, and we have an El Niño, these trade winds do not blow this direction very well. That warm color you see there, it's not temperature. That is the westerly component of the trade winds. It's an anomaly, which means at times we get very weak trade winds or sometimes a stop or reverse. And that is the key. Now remember, this is a vertical circulation. This is down here near the surface. When you go up in the atmosphere, you get the winds going the other direction, see? Now at aloft, 6 miles above our heads, the winds are screaming out of this direction. And that is what Sir Gilbert Walker discovered. The oscillations in his Walker cell, which is what we described a few moments ago, are exactly what we're seeing. Now we have been studying this in earnest since the 1950s. And since then, one of the most important things for North America is this. You see, when those winds are really strong in this direction of the equator, we also have a lower westerly component of the winds here. Now, you can't look at these colors and assume the same behavior because the trade winds are what's dominating this. When we're looking up in this area, this actually means that along the west coast of the United States, the flow typically splits like this. And it comes over the top into the Canadian prairie, dives into the Midwest. A southerly component cuts around from the bottom, and it all eventually exits east. So if anybody says, what does El Nino mean? It means a flow pattern that splits over the west in summer and does something like that. That is the average. Now, every El Nino has a different flavor, but that is what the typical pattern is. And how we monitor this is we look for the changes in the ocean temperatures and the changes in the trade winds. And I told you we've been studying this since the 1950s, and I've shown you this graphic many times. What I want to do is this. We have a very specific set of events going on right now. A handful of times, I can find about a dozen times in history, we have come out of a stronger La Nina, the colder phase, where everything I just shared with you is the opposite, and we've gone straight into a strong El Nino, like we did in 1972. Or you could say we did this in 1982 or back in 1997 or 2015, but there's also like 2009. There's also years in here like, what about 1986? So what I've done is I've taken all these years where we've come out of a La Nina and gone into an El Nino and said, well, what did the atmosphere do? And it's pretty nice. When you look at the upper levels of the atmosphere, now this is at the jet stream level, the winds are going this way and that way. Now, those are diverging lines, but you're the upper level of the atmosphere. In other words, to get the air, it's got to rise and then split, which means there's rising motion here. And that is exactly what happens when there is an El Nino. Now, what does that do to the northern hemisphere? Well, remember, this is not troughs and ridges. This is the zonal wind component. That means it's got to split around this, more north-south flow, stronger coming around it, and it zips together right back in the middle part of the country. Now, as I stated a moment ago, we have had back-to-back La Nina events. We've had that in history where there's been repeated La Nina events. Most of them are back-to-back. We've had one other instance where they've been back-to-back-to-back, okay? And this is what it did. The first year of it, starting on July the 1st in 2020, we saw the beginning effects of La Nina taking hold. And from July 1st, 2020 to June 30th, 2021, we saw the drought initially in the west, okay? And so that is where we went over driest first, and then it hit parts of the the northern plains, and got a little bit into the northeast. This was the year where we hit Iowa, this side of Iowa, pretty hard with the drought. Now, as we got then into the next year, so this is going to be July 1st, 2021 through June 30th, 2022, we saw that drought migrate and establish itself primarily here, but also still over parts of the Southwest and a bit over the Carolinas. To the north of it, very wet. That's where all the strong winds were. Then now we're going to look at last year, starting on July 1st and going up until March 1st when this La Nina finally let go. So what I just do, this is 3 years of La Nina. And the question is, are we beating this back, and will we continue to fill in the holes? Because typically La Ninas deliver drought and El Ninos tend to make more precipitation. That is the ultimate question that we are attempting to answer. We have already seen a lot of precipitation hit this area in the month of May. Now remember, this only goes up to March 1st. We've eaten away at that. But we've watched some points to the east of it getting drier. And have you noticed there's been kind of this west-to-east progression of the dryness? The question is, will we break out of the bottom of this and really start to accelerate up quickly? We've already seen this particular El Nino move at a greater pace than what we had originally anticipated. Go back to the beginning of March. Up until now, it has come up over a full degree Celsius with the ocean temperatures in the central equatorial Pacific Ocean. We've also seen that lately the sea surface temperatures have really been changing a lot, eroding our negative PDO signal, especially right in through here. We're going to come back to that in a few moments. So what I'm saying is that the pace of this particular event, this El Nino developing, it's there, it's going to influence the pattern. And right now we're sitting, though, with this risk of being drier in the near term, but we're waiting to see when is the moisture going to get here. Because I'll tell you, we still see from the surface of the Pacific Ocean, from South America over to Indonesia, that there's warm water that will continue to surface as the trade winds slacken. So what does all of this mean? Well, these waters are going to continue to get warmer. We expect this colder water signal right in through here, which is still the remaining part of the negative PDO, we expect it to fade over the next 30 to 60 days. And as that warmer water continues to push into British Columbia toward the Pacific Northwest, the risk is to get the jet stream to split like this. It's not doing that now. Currently it's coming in and it's splitting here. And that is why this section of the country is so very dry right now. But those are the factors that we're watching right now going forward to see if this La Nina transitioning to El Nino is actually going to manifest itself with summer rainfall in the midsection of the United States. So I want to remind you something. May and June, for all of those years, they're all listed up here, where we transitioned out of a La Nina into an El Nino, we were dry here. We talked about this on Monday. This whole area from the whole of the Mississippi Basin into the Ohio Basin, we were dry. It was wetter in the southeast, and it has been wetter lately in the southeast. What's not been the same is what's going on here in the northeast. But you stitch together all of those years, and you can see the composites. So we bring this up because we're just looking for the signs that tell us El Nino is still on its way, and it might come to the point where it can deliver the moisture out of the flow pattern we're in. So what do I see happening? All of these reds indicate, like we saw earlier, where there's westerly wind bursts happening across the Pacific Ocean. For the last 3 years, all I've showed you in these areas here was just solid blue indicating strong trade winds. Not anymore. They're over here. And what this is doing is the flow in the low levels is going that direction, and in the low levels on the other side, it's going from this direction, and therefore in between, the atmosphere has sinking motion. And over the next several days, we're going to watch the sinking motion move right here over Indonesia, Malaysia, and Australia. Now, what did we learn coming back to the beginning? That's what we typically get, sinking motion here, when El Nino begins to take a hold of what the pattern is up to. So thinking about that, let's get you queued back up here. I want to remind you that the newest updates we have on the strength of this El Nino are still going after aggressively warmer ocean temperatures through the next 6 months. The Bureau of Meteorology out of Australia is still projecting somewhere between 2.4 and 2.8 degrees C above average. That would rank this particular El Nino event up here with the 15-16 event, the 97-98, and the 82-83, if it gets there by the time we get into late summer and fall. From there, I want to point out that what it's doing in the near term is that it is really messing with the position and strength of the, let's go back to here, the position and the strength of the jet stream. And this is typical of an El Nino in May and June. Sorry, as that loads there, I apologize that that's slow. It's got the jet retracted. It's just barely coming off of Japan, meandering its way across the Pacific, and then splitting here. And that void in the middle is where we're worried about the dry conditions. So I'd like to show it to you. This is what the jet stream looks like right now. A tremendous amount of momentum in the southern hemisphere, very weak and low momentum in the northern hemisphere. So as we just play this out here through the rest of this weekend into next week, do you see it? There's the less than stellar jet coming off of China and Japan. Here's the subtropical component feeding all the storms that are coming up the front range of the mountains. But there's a trough here, and the flow splits. And that split weak flow is right there. Now, there is a typhoon sneaking in underneath this. It's a big one. It's going right toward Taiwan in the near term. We are hoping that it's going to energize this jet and start to push it back out. And as we look out there towards June 3rd, June 4th, June 5th, we start to see some indications that the jet could begin its extension. The bad part about that is that takes the split and moves it west. Now that is bad for the west, better for the Midwest. But this change will not likely be happening until after we get past the first full week of the month of June. So that is why the next 7 days look something like this. Repeated storms here. Now I got to ask a great question this morning. Why? Why are the storms there? Well, the jet is coming around. It's got a little bit of southwest flow to it like this. Those are troughs. Troughs, when they go over the mountains, have their spin enhanced. And what that does is that it causes a trigger, allows the air to begin to rise. The second thing is, without strong jet stream flow coming through, because remember, the jet's coming in, the jet's coming in like this and then just splitting and going very weakly around everything. All right, because of that, we're able to see this moisture get pretty far back to the mountains. In other words, the dry line is farther to the west. And therefore, because of the upslope flow and the short waves coming over the top and the fact that they're not moving because there's nothing downwind to get them keep going, it's just going to storm. It's going to storm a lot in this area from El Paso clear to Billings and all the way up to Saskatoon and all the way here over to parts of Manitoba. The other factor is that we're still watching this low that's going to curl up later this weekend and deliver rain into parts of North and South Carolina, two places that desperately need to get more precipitation right now. This is it. This is our pattern through the next 7 days. Now we say, what about the following time period? Well, here's that split weak flow. Right in here's your problem. The spacing of the isobars tells you the wind speed. The colors tell you the height, okay? So where it's hot, high. Where it's colder, or where it's blue, heights are lower and it's colder. So the fastest winds are where they're tucked together tight. So there's fast winds here, there's fast winds here, and there's just nothing in between. In fact, if you were to, climb an imaginary ladder up to the jet stream level from Lincoln, Nebraska, you'd find that the winds at the top are about the same as they are at the surface, and they're nothing. But if we keep playing this out there to June 5th, 6th, and 7th, do you see what the model's doing? We're getting some early hints of moving the ridge, which was here, to there. And we're also now seeing the spacing of the isobars come together. And that is what we're watching for. That's it. That's the trick. So going out there and looking at week 2, we continue to see the wet conditions here. But the models are attempting to trend wetter in this area, but not until after this date. So 2 more weeks. You've got 2 more weeks of running this risk of drier conditions, which means we have to talk about the temperatures here in a few moments. But I see all of this and I say, all right, what are those temperatures up to? Because we have this cold front that came through, and we still have today, going into tomorrow morning, Friday morning, frost and freeze advisories. And that's because this cold front, you can see it in the cloud field right here. This cold front has been quite impressive as it sinks farther and farther to the south. But underneath this, the shield of clouds you see here, there's a lot of storms that are firing up the mountains yet again today. And they're going to keep doing it the next 3, 4, 5, 6, 7 days, all along this area. Again, from Texas all the way to Montana into the Canadian prairie. Now, we have been concerned that getting to the end of May and the first couple of days of June, we're going to watch out for some excessive heat here. Now remember, excessive heat in early June, like the 2nd and 3rd, is temperatures in the 90s. And just pulling up the latest data from the European model, I want to show you what these temperatures are going to do. So here's the colder weather that's in place right now through Saturday into Sunday. But watch the heat. Each day you get kind of a flash of it. You see the heat coming in here. By the way, this is all cloud cover from storms. That's why that's cooler. And it's cooler here because of cloud cover and all the rain from the system coming up out of Florida. But as I play this forward, what I'll be watching for is I put a contour at 90 degrees Fahrenheit. And this is 1 o'clock in the afternoon on Tuesday. And now you start to see that in Iowa, Missouri, all the way down here to parts of Arkansas, Louisiana, Mississippi, gets into Illinois and Indiana as well. That's Tuesday's high temperatures. And then on Wednesday, we're going to crack 90, maybe getting into the low to mid 90s here. And it's going to be dry. The humidity levels are going to be very low. And therefore, this is going to promote some very high evaporation rates. If you put the whole week together, we're looking at something like at least 1/3 of an inch a day, so over 2 inches of evaporation. So this is a stressor overall. But we want to know, is it going to last? And as we just go forward, this is Thursday, another hot day. So that's that time period. Remember, the end of May, the beginning of June. But we do start to see the models attempting to push this farther out of the way, farther to the south, and bring in some relief by the time we get to the 3rd. And watch this. The 5-day average, looking at a sliding window here of temperature anomalies through the next 10 days, that's where the warmth is. It's here back up in the Canadian prairie. And then we just keep going out. And as the ridge slides west, we get to see the cooler temperatures coming back to this area. So there's a short duration heat wave that is coming to this part of the Midwest. We stay cooler in this corridor because of constant storms. We stay cooler than normal over the Southwest because of now the split coming here. And what we need to watch is after the 7th, 8th, and 9th, does the pattern begin to be more conducive to giving us storms? And here's where we get to the answer of that. Can we say that the ECMWF's forecast of the MJO is helping? Probably not. I think the ECMWF's forecast of the MJO is largely being influenced right now by the fact that the Southern Oscillation Index has just plummeted. It was once way up there, and it has now since just dropped way down. Oops, sorry about that. Something's up with my new machine here. There we go. Way down here like this. But I can almost blame all of that on the fact that there's a big typhoon sitting here that's on its way over the next few days toward Taiwan. It'll likely make the turn and go up toward Japan, not hit mainland China, but there it is coming toward it. I think all of that action in the MJO and the stuff that's going on with the Southern Oscillation Index is because of that. So here's what I wanted to get you to. The new week 3, week 4 outlook from the CPC has a corridor in through here that's wetter. And then you can see that's week 3. So by the way, that's the 8th through the 14th. And now we see the 15th through the 21st showing up wetter in this area. And can we back that up with what's going on right now with some other forecasting sources? Well, let's see if we can get this to reload. There we go. This is the latest data from the Climate Prediction Center as processed by Victor Cassini out of Northern Illinois University. So we have storms right now this week here. We're going to suppress those storms pretty far to the south into week 2. And then you can see that by week 3, there are some indications that we open this all back up to a lot more thunderstorm activity. Don't mind the colors. I'm just looking for any indication of bringing these storms back into place. From there, I want to show you what the European model is saying. This is the next 7 days. We've already discussed why this looks this way. You've even seen, whoops, went a little fast there. This is week 2. Now watch, as we go past the 9th, this is the week 3 forecast. And there's that corridor opening up to storms. And we go, and that's mid-June. We go into the end of June. And now we start to see more thunderstorm activity happening here. So we are on this time period where for the next, I guess, 13 to 15 days, if you are in this region, we are not getting much. And a lot of us are worried about that because over the last 30 days, that has been our area that has really missed out on a lot of precipitation. Now we've also got it drier here, a couple of pockets east, but there's just a larger concentration of drier weather, and probably the epicenter of it is right into this area of Nebraska getting into Iowa. So are we going to make some changes to this? Because the latest drought monitor released today increased some of the drought area in parts of the central and eastern Corn Belt while reducing it in Colorado. In fact, let's just go look at this. If we go to the change maps, and we don't do 1 week. Well, let's look at 1 week. These are the places where the classes have improved. The yellows are where it's gotten worse. But if we look back over 4 weeks, this tells us what the end of April and most of May has done. So it's gotten worse in parts of Nebraska, Missouri, Illinois. And we've also seen it getting very dry in Michigan, although not yet showing up on the drought monitor. And you've seen where the improvements have been, up to a 4-class improvement in parts of Colorado. So I get it. This is what the big concern is. Can the newly planted crop in this area make it another 10 to 12 days, knowing there's some heat coming in mid to late next week right into this area that could just put some really stress on the crop? And are we right in the fact that the models want to bring storms back into that area after that time period? I have indications, I have model trends, I have the meteorology to back it up, the history to back it up, but you know how the atmosphere is. So we'll watch this together to see what it can produce. Last couple of things to talk about quickly. The National Weather Service and the National Hurricane Center issued their latest update on the hurricane season today. This went kind of viral on social media, but what it's showing you here is that the probability of a near normal season seems to be the highest. And one of the things that they're concerned about, which we all are, which is what, if you want to read the article, you can do that, is that the ocean temperatures here and where we grow these hurricanes later on in the year is actually very warm for this time of year. I've got one last piece to share with you tonight, and that is what's going on in South America. Just want to show you that the models have been consistent with delivering the rains here this weekend into early next week, and that hits some key crop area down here in southern Brazil's main growing area for the safrinha crop. and that could be important for finishing that crop as we finish up a season in South America and go headlong into one in North America. So I'm going to stop there, and I look forward to talking again after the weekend. Have a good one. Thanks.